MCQ 28 is with regards to the hydrolysis of protein. So in this question here, we're given chymotrypsin, an enzyme that hydrolyzes peptide bond on the carboxyl side of a residue that comes with an aromatic ring. So in this case here, if you take a look at W, we have an aromatic ring here, as well as another aromatic ring over here. As you can see, this will cause the cleavage to be on the carboxyl side of that residue. So I do have a cleavage over here, and I do have another cleavage over here. So from here, you can see that I'm generating W. I am generating Y. And lastly, I'm generating X. But because for residue X as well as residue Y, you see that there's actually a peptide bond that is left behind. Now, each peptide bond is found between two amino acids. So if you have two peptide bonds, it will be found between three amino acids. So for the case of X itself, because it contains two amino acids, X is considered to be a dipeptide. Similarly, for the case of Y, because there are two amino acids, it is also considered to be as a dipeptide as well. So the question has a condition of after going through the digestion with chymotrypsin, we want to generate two different dipeptides. So starting off with option A, we do see a single benzene ring over here. And from that, the cleavage will be seen over at this area. And through this cleavage itself, if you take a look at what's left behind, we do have only one amino acid that's left behind. So this is definitely not considered to be a dipeptide. But the remnants over here that's left behind actually contains one as well as two peptide bonds. And from that, there are three amino acids, meaning that for A, we're left behind with a tripeptide. This is not what we are looking here for, so A is out. Now take a look at the case of B. We have two benzene rings. So we should be expecting two cleavages on the carboxyl side. So we're going to have one of it here, and we're going to have one of it over here as well. So post cleavage itself, you're left with one amino acid. The residue that's in the middle is also considered to have only one amino acid. And the final residue on the leftmost side has one peptide bond that's left behind, which means that it's made up of two amino acids. And that means that we do have a dipeptide. Now, however, we want two dipeptides to be formed, so B is out from that. Take a look at C. We do have also two benzene rings. However, the rightmost benzene ring doesn't have any peptide bond, so it will not be going for any form of cleavage. Only the leftmost one will be going for a cleavage over here. So what we're left behind, we do have a single peptide bond. So that means that this is made up of two amino acids. We're looking at a dipeptide here. And this is the remnants of the remaining part of the cleavage. Again, we do see that there is also the generation of another peptide bond, which means that there are two amino acids and another dipeptide. And on further investigation, they definitely do not look the same, so C will be the answer. But just for the sake of completion to see why option D is wrong, we have benzene ring, and we have another benzene ring. So you should be expecting two sets of cleavage. So we're going to have one of it here, and the next one will actually be over here. So doing the final count over here, this is going to be a single amino acid. and also another single amino acid. But for the remaining, we do see that there is actually a peptide bond that's left behind. So this is 2 amino acid, and there's a presence of 1 single dipeptide, which is not what the question actually intended. So in this case here, C is the correct answer.